Okay.
Okay.
So take your spreadsheet and reformat all the cells in this region to have no values after the decimal point.
Okay.
Right, so
I'll
just highlight all of the values. And then once you've highlighted all the values, you can right click. Let me see where, or you go into Format Cells, which we'll find somewhere. And you should be able to, oh yes, you can do it up above. You see where it says increase decimal places and decrease decimal places?
Yeah.
Right? Just start decreasing the decimal places. There you go. One more.
Okay. Done.
Okay, that's all done. Good. Then the next thing is you can take the three values that I've highlighted in red and highlight those in red for a second, and then I'll explain what's going on there. Yeah, changing the font to red makes it a little easier if you know how to do that. So instead of using the highlight.
Oh, okay. Oh, I see what you mean.
So up at the top, you have font color, text color.
Yeah.
So the fill color should still be no fill. So just undo that and then change the font color to red.
Okay. I'm seeing
Those
something.
three values are glitches. They're that the electronics was not working correctly.
Okay.
And so what it meant is that it read an infinite resistance.
Mm-hmm.
So for those values, I would recommend deleting them.
Okay.
Okay? Because they're not useful data. And when you try to do ratios with them, that's not useful data either. And when I do that, I can take some of these columns and I can make them, or many of the columns, I can make them narrower, which makes it just a little easier to work with the spreadsheet. Takes up less space. So I'm just going to narrow those columns. And that just gives me a little more space. A little bit too far. Okay, so you have that. So then you'll get some of these divide by zero errors. And don't worry about those for right now. But the columns that have none of those red values in them were test 1. Here, this one had none. And so instead of dividing test 13 by test 2, I recommend dividing test 13 by test 1. Now, when you look at what you actually have, if I go to column N, as in Nancy, you're actually dividing by test 2, not test 1. Do you see how you're doing M4 divided by C4?
Oh yes. Yeah. Okay. Yeah.
It could be M4 divided by B4. Change that and copy it all the way down.
On the ratio part, I have a question. So out of these tests, so that's why I kind of like did not finish that part. Out of all these tests, how which one are you like, how do I know which one like I had to choose? Or like do I have to do for each test?
I
Um,
think it's
yeah, go ahead, Jeff.
well, just from knowing how I tested, he's testing the fully saturated acetone, or sorry, he's making a ratio of the fully saturated acetone, fully saturated ethanol. And so you know that by the tests I listed in our email where and I also have it in my notes of when we tested those, essentially. I'm guessing is why that's the way it is.
No, my question is, how we do the ratio? Like I know how to do it, but
Oh,
decided which test would be because, for example, for like ethanol, we did like 3 of them. For acetal, we did 3 of them. Do I have to do like the ratio for each one of them, or do I have to just choose one? That's,
I see what she's asking.
yeah,
Yeah,
because I did like I got
it's a good question. The reason we do 3 of them to check and see if they're consistent.
And then which ratio do we output?
So if I now go and show you the data here, so we ran 3 ambient air tests,
yes.
okay? And what we're seeing, in fact, let me just do this by row. You see how these 3 numbers, they're basically the same. And these 3 numbers, they're basically the same. And the first and last ones are the same. There was just a glitch in the middle one. As long as they are basically the same, it doesn't matter which one of the 3 you pick. It's kind of just checking to make sure that the testing is running consistently.
Okay.
Okay, so the answer is you'd need to run 3 just to make sure that things are consistent, and because you can do that fairly quickly. And so that you have extra data in case there's glitches and things, but otherwise it's okay. So we just took a simplification and said, let's use test 13 because there were no glitches and it's basically the same results for saturated ethanol. And one of the first three tests, but if you did test 13 divided by test 1, you're not going to get much difference. Okay, now the next thing in that column that you call test 13 divided by test 1, your audience tomorrow is not going to understand that, and you don't need to explain that. Just in there somewhere, you see what I did. I called it ethanol, and then I wrote test 13 over test 1. Change that label so that it would be clear to your audience.
Okay. Oh, I think test 30 would be ethanol, not.
Yeah, it's this column here.
Yeah.
Column
Okay.
O. We haven't done
Yes.
column N yet. We'll do that next.
Okay.
Okay,
Yeah,
so
done.
just call it ethanol, test 13 divided by test 1.
Okay.
Okay, and then I would do it in multiple columns so that it can fit more ease. Well, actually, that's not that big of a deal, right? So but make sure that we can read all of it. Yeah, ethanol test 13 divided by test 1. Now, insert a column to the left, and that's going to be your acetone test. right? So that's going to be acetone, and that's going to be test. I just used test 5 divided by test 1, and then go and put that information in there, right? And that's going to be F4 for test 5 divided by B4, and then copy that down.
Yeah, done.
Okay, now you have too many unnecessary significant digits. So take those two columns and just put two decimals after, or 2 digits after the decimal point. Okay, and then center the data so it's easier to work with.
Do what?
Center the data. So
To or
click
to
on the
oh
top.
center. Okay, okay. I heard like center. Okay, get it.
So center that data. You haven't centered it yet. You
Okay.
you see up at the top, you have a symbol that allows you to take the data and have it show up in the middle. You have one called horizontal align, and if you highlight the column, you can get all the data in the column to all be in the middle, like what I'm showing you here.
Sorry, I think I missed that.
Highlight the column.
Yeah, I did.
Okay, I don't see the column highlighted. If I highlight a column, it would go like that.
Just the column that is acetone. Yeah, I highlighted it. Okay.
Okay, and then go at the top. You have a symbol which, in fact, let me just stop share so you can see where I'm pointing.
Vertical.
At the top, you have a symbol here. It's called horizontal align. You see it? You see
Yes.
where my pointer is?
Yes.
Okay, click that and click the down arrow next to it.
Yeah.
Okay, and then go for the middle of the 3 options. There you go. And then do that. Yeah, both columns, perfect. Okay, so now you have the data. And now we're going to do something that I haven't done on mine yet, and I'm going to show it to you. So that we can organize this data in a way that's going to be easier for people to see and work with. I'm going to insert 2 columns here to the left. And I'm going to take my ratio data and I'm going to move it over there. Okay, because now when I've done that, and I can get rid of these 2 columns. And now when I make these columns show all of the data, I think you didn't do cut and paste, you tried to do copy.
Yeah, that's what I did.
Right? And make sure that you're putting there you go. Okay, so now you got it. The acetone test. Whoops.
No, I need to go a little bit down. That's why
Okay, yeah.
it's not representing the sensor correctly. Okay, for some reason the data is not okay. Okay, I think it's working now.
Yeah, that looks good. Make those two columns wide enough so that the label at the top is completely readable. Okay, that all looks very good. I would also recommend that you now put boxes around all of the cells so that that becomes clean and readable. Like that. Okay, just for those two columns. And now what we need to do, and I don't know if this exists, is I want to see if I highlight those two columns, do I have the ability to do conditional formatting?
Which two?
I'm checking now to see. I don't think that feature exists in the Google Docs version. But it makes it very useful because that's how I got the colors out. And so you may need to download this, or I can send this to you so you can understand what it is. Because what we care about is that section there, and with its colors, and then I'm going to show you what we're going to do with that. So if I go into, yeah, let me, oh, not there yet. I need to set that as the print area. I then can close this. I then, whoops, I need to go File. I will print just that section. And now let me show you on my big screen what we're going to do. Okay, and I can send this to you, and then at some point I need to, if you download it into Excel, I can show you how you get the colors, but for now, I'm not so concerned about you doing that. So there I have, now this is all very small, but I'm going to make it bigger. Now I have the data. And I'm going to make that data so that it's big enough for you to see. Right? That should be pretty visible.
Okay.
It's good.
And that's, I'm going to send that to you, and I suggest you copy and paste it into tomorrow morning's presentation. And then you also copy and paste the 2022 data. Let me make that a little bit bigger. Why am I not seeing the scale on this? Okay, let me bring that up differently so I can see the scale. Oh, this will do it. Okay, if I now go in and there it is. Why couldn't I see it before? Just a second. No, it doesn't give it to me. Okay, so with this one, I can come in, I can make it much, much bigger. Go to that section. Enlarge it even further. All right, now we have something useful. Okay, so you see that data. And this is what we want to compare. And this is what I would put all of this onto one slide because it shows the story. All right. So we
Yeah.
have 2620s reacting to acetone and ethanol. 2620s are the column here. And we're at, you should be at 3.7 volts. And you got a 0.9 for acetone, and you got a 0.9, they got a 0.75. So we have to check. One of the discussion topics is to make sure that they had it set at 3.7 volts. Because if it wasn't at 3.7 volts, you see that the signal is not as good, right? It didn't drop it as much. So that may be a problem, something that wasn't set correctly on the 2620. If we look at ethanol, ethanol is not on here, but isopropanol is, which is somewhat similar. But ethanol behaved differently, which is very cool. So we're starting to get good data on ethanol. No issues or comments there. Now we look at the 2600s. The 2600s in acetone did not behave correctly. You see how they should have responded and they didn't?
They should have responded with acetone 2600. Oh, okay.
2600s on your tests are showing a 1.0 for acetone,
Shows nothing, right? Shows no
right?
reading.
So there's something wrong with the 2600s.
Okay.
Okay. Then I'm going to skip. I'm going to do the 2602s first. The 2602s, you see they reacted pretty strong with acetone. 2602s, that's pretty good, but not as much as they should have. I think there's something where the voltages are not set correctly. The 2620s, 2620s should not have reacted, and they did react. So that's strange too. And then we have, right? So these 2620s reacted differently than these 2620s. See that?
Mm-hmm.
All of that needs to be discussed tomorrow.
Can we go over what
2610s behaved differently. You see, we had 4 2610s. 2 of them behaved the way we would expect, and 2 did not react. You see all of that?
Yes, my question, are you only looking for the voltage 3.7? And if it is so, why only 3.7? Why not 3.3 and also the rest of them?
This gets set in the configuration file And tomorrow in the meeting, because I can't be there, you need to ask about that configuration file and ask them whether all the sensors were set to 3.7 volts or not. Can you make sure you have that in your notes to ask?
Yeah, I'm
got it.
right.
Okay,
Okay.
then we get,
Oh, sorry, can we go over which, so we had 2610, 2 behaved correctly, 2 didn't. And then we have 2620 and that, sorry, my split screen makes it a little difficult for me to see. What happened with 2620?
2620s reacted on the left and should not have reacted according to what we learned, what we did in 2 years ago.
Okay, so I have 2610, 2620, and then we wanted the 2600, right?
Ah, yes, but actually, it's even more complicated. There are 2620s in the top 2 rows on the left.
2602.
And then there are 2620s in
Sorry.
location 10, which is most of the way down.
Sorry, I kind of lost you for a second there. What did
Okay, on the screen, on the left, the first 2 data points are 2620s.
Yep.
In acetone, they're 0.9 and 0.92.
Yeah.
Okay, then you go down and you get to location 10, has 2 2620s in it. See location 10. And the 2 2620s there were 0.12 and 0.13.
For 2620.
And
acetone?
location 10, L10 underscore C1 and L10 underscore C7,
Yes.
right?
Oh, that was for us. Yeah, that was for us. Okay, sorry, I was looking at
Yeah,
the
for
2
you. Yeah, for you.
Yep.
So
Okay.
you have 2 other 2620s that behave differently than the ones that are in the top 2 rows for you. That can't be.
Okay.
Okay, so that's the kinds of debugging that needs to happen.
Okay.
Okay, so the team that's working on the instrument needs to look at these values. The same way, if you see starting in row 5 on your data, you have an NO2, and then 3 rows lower, you have another NO2. And those 2 NO2s behave the same, 0.94 and 0.93. Then you have some CO sensors. Okay, the first one was 0.99, the second one was 0.25. That can't be. You see that? And
Yeah.
then you have 2 NH3s, 0.96 and 0.95. That's okay. So comparing this data from the different sensors in your tests to each other, and then comparing it to the data that was done in 2021 with the other instrument, tells us where there are problems with the instrument. That's what needs to be reviewed in the talk in the meeting tomorrow morning at 8.
Okay.
Zabiba, do you have any questions on that?
I don't have any question, but I'm trying to find the the pattern recognition one that you have it. I'm just trying to find where could I find that one so I can compare it to the other one.
That one's in the Google Drive from 21 to 22 senior design project, the E-Days one.
E-Days poster 22-21 or 21-22 senior design.
Okay.
Yeah, that becomes our starting point for everything that we're doing.
Okay.
And this is what needs to be shared with the team. And then we have to decide what tests you're going to run on Thursday. And for that, I think we need to see what the team can do in terms of fixing or substituting some of the sensors to see if that improves anything. And the hardware team or you as a team, if you could in the next day tell me what other compounds you have available in the cabinet, I can tell you which compounds would be the next good ones to run.
We have it somewhere written that one. I can't even figure it out that right now.
Yeah, why don't you dig that up now?
Okay, while I'm doing that, we cannot do Thursday, this for the testing, we cannot do on Thursday. I have, so Jeff have time opens Thursday at 1 and I only have 1 to 2 because I have lab and they are also using the lab on Thursday as well. So I did suggest, I don't know if Jeff would be available, but I'm available Tuesday from 12 to 2 and Wednesday 12 to 2.
Okay, both of those days I have class until 1.
Oh, okay. Maybe I can go and set up and stuff. Then
So
you can join me at 1, maybe.
Okay. Would the device be ready to go by then though, considering?
I think, well, first off, I want to check something. So Biba, when we were going through this, let me find. So when I look at the information you sent me, Zabiba, yeah, so the lab runs until 1 o'clock on Thursday.
Yes, and then from they have at 3 or 3:30. But my problem is Jeff would be available at 1, and I'm not gonna be available after I have class at 2, which I have to work away from the lab at least 1:45 because my class is a little bit far from Scott. So we have only in between 45 minutes.
So tomorrow, Jev and Zabiba, see who else you can find to help when Zabiba is no longer available. So just like last week, we need to continue to test every week. Thursday is probably the best day. So see who else, and it could be Jared, it could be Aaron, it could be Brooke, it could be someone else from the team as a second person.
I'll just add that I have a slide going of like the thing about the configuration, and I'll also add that as a question for the team.
Good.
I'm gonna say test on Thursday 1 to 3. Oh wait, do they have something at 3? Did we say that? That there's something at 3 on Thursday?
There is.
They do Thursday. They are okay. Thursday they're scheduled for the lab availability is 9. Okay. They are. Yeah. Okay. 9 a.m. to 12:50 p.m. is not available, and then 3:30 to 5:20 is not available. But
Okay, perfect. 1 to 3, perfect. And we'll just ask someone and I'll run the tests.
Yeah.
yeah,
1 to
if
3
there
is
is
gonna
no
be
one
perfect.
available, but I can do either Tuesday 12 to 2, which Jay would join me at 1, and I can start setting up stuff, and by the time she comes, so we can just start like the testing.
That doesn't give enough time for the team to fix the instrument.
Okay.
Okay, so you're only reporting this data tomorrow, and between 9 and noon is not enough time for them to take the instrument apart, rework it, and then put it back together.
Yeah, but I'm also available Wednesday, same time.
I think that might also be tight, and I don't know what's Jeb, what is your schedule on Wednesday?
So we'll only be able to test from 1 to 2 on that day if it was 12. Like I have a class from 12 to 1.
Let's stick with Thursday.
Okay. Zabiba, for the presentation, I was going to list out all the differences that okay, so I think the issue with having all of these things on the slide deck is that like we're just gonna have a bunch of numbers and we're gonna say which is working and which isn't like compared to the E-Days chart. And I'm wondering if it would be best to just explain to them how to read the chart, so then they know, like, we don't have to have everything listed and all these values out that might get kind of jumbling. So we should explain to them, for example, if there's a different reading for the 2620 on what we tested and then different compared to the E-Days chart, then that's something that we need to look at. Because it's kind of difficult. I guess what I'm trying to do is I want to make it concise for the team so they can look and know what they need to fix. But it's also kind of difficult to just list out all the sensors and exactly how they're differing for the 2610, 2600, and 602.
So my recommendation is, you see what I'm doing here. You should have this take a cut and show what I'm showing you here.
I don't see. Are you
Oh, I
showing
got
it?
it. Oh, sorry. Yep, that's my bad.
No problem. Oh, cool.
Okay.
Yeah.
You need
Mhm.
this data on a slide.
Okay.
Okay.
Cool. Yeah.
So just cut out the fall 2021 data and cut out, and I'll send you the cutout version of the data on the left.
Okay.
Okay.
Do we
That,
also want the isopropanol data for that one, for the E-Days poster?
I'd skip it, right? Because there's
Okay.
just because ethanol and isopropanol are a little bit different. You do want to share both. Just show this and explain what the problems are with the acetone data on the Sniftek 36 and talk through what can be done about it.
Okay.
Okay?
Yep.
I can screenshot that. I mean,
In fact, what I can do is, yeah, I'll just send you these 2 screenshots.
Okay.
Okay, that's probably the easiest way. And then it's pretty straightforward for you to do all the other things you need to do.
Okay.
I'm ready for to let you know what compound do we have.
So Zabiba, I didn't really understand what you were saying.
No, you said you want to know what compound do we have in the lab, so you can tell us which one should we
Oh,
use.
yes. Just a second. Let me just
Yeah. Won't even do it.
got that one. Let me save the other one. Okay, I'm ready.
Okay, we have ethanol, heptanol, nonal, acetone, acetaldehyde, phenol, isopropanol, methylpropanol, and octanol.
So you have acetone. Do you have isopropanol?
Yes.
Okay, good. You could do that. Do you have ethyl butyrate?
No.
Okay. Do you have isoprene?
No.
You do have butyl aldehyde?
I don't have butylaldehyde. I have heptanol and nonal.
Heptanol and nonanol. All right. Let's run. Let me just see. 2600s, we still have questions on, so we're not going to run nonanol.
We also
Isopropanol and acetone basically look the same. Isopropanol would be a pretty good one. You don't have ethyl butyrate. You do have heptanol. Heptanol is run acetone and isopropanol.
okay.
Okay?
Okay.
Same type of testing, same type of analysis, and see if you can work through all of the steps and see if the hardware team can make the improvements.
Okay, I'm gonna call what I did last week with the like saturating the resistors before recording the test. I'm gonna call this the saturated testing approach.
Good.
If that's
Yep. That's all great.
so acetone and isopropanol fully saturated. Okay, great. You got it.
Okay, excellent. I think this is working.
Yeah, I think this is a good way to test.
Yeah. Any other questions?
I don't think so. We'll figure
Uh,
out testing stuff by tomorrow.
Yeah, this is great. Okay, I'm gonna let you go. Good luck tomorrow, and then we'll talk more afterwards.
Great. Okay. See you then.
Okay.
Bye.
Bye.